Hi guys. My name is David White, and in this video, I'll be explaining what linear regression is, and I'll be explaining for two classes of people: people that have lots of experience in machine learning and AI and deep learning and all that, data science, and people who don't have so much experience. Yeah, so I'll be explaining for these two classes of people. So let me start with no, let me start with people who let me start with people who don't have so much experience or so much mathematical or engineering background. Just people who are probably new into machine learning or deep learning. So linear regression is basically a process of you drawing a line between on a graph, and that line basically shows you relationship between two variables, x and y. So that's like the simple definition for people who don't have so much data science or engineering backgrounds or mathematical backgrounds. So and if I'm to explain a little bit deeper, so usually in machine learning you're trying to predict something. Let's say you're trying to predict the number of students who pass an exam, and you're trying to predict that a student will pass an exam based on how many times he attended class. So basically you have like lots of data, and then you're just trying to draw a line that shows you the relationship, and with that line you can predict whether a student will pass an exam based on how many times he was in class. So yeah, that's like a good explanation. So for people who are more advanced, who have mathematical backgrounds or data science backgrounds or engineering or software engineering backgrounds, so I'll give a more detailed explanation of what linear regression is. So for these guys, linear regression is a way of modeling relationship between two variables. So it could be between multiple variables too. So for simple linear regression, it will be between two variables, x and y. For multiple linear regression, for multivariate linear regression, you would have multiple variables basically, and then it gets more complex. But for the sake of explaining and visualizing, because we'll not be able to really visualize like different dimensions here on this 2D screen, so we'll just stick with the simple linear regression. So back to the previous example that I gave, but before we go into that, let's break down what linear regression is. So you have linear and you have regression. So linear basically is just telling you, linear basically just screams straight line. So when you say linear in the mathematical world or in the engineering world, we're just talking about a straight line. Like, it screams straight line. So, and then when you say regression, it just basically have to do with movement, and a movement in a particular direction. So that's why you have things like you have words like progression and stuff like that. So for regression, it's mostly like, if you're looking at it from the English point of view, it's mostly like just saying something is coming down, regressing, moving downwards. You can see someone's health is regressing, or a particular value or variable is regressing, basically. So if you put those together, you get what what comes to mind when you hear the word linear regression. So coming back to machine learning, so the example I gave before was talking about predicting whether a student will pass an exam or fail an exam based on the score. No, based on the attendance of the student in class. So yeah. So let's and then usually in machine learning you always have this try to say standard equation here. So let's just say, oh no, let's use this guy. Y equals to mx plus, let's say c. So yeah, so once you have these, you can see that you have y equals to mx plus c. So x, let's say this x represents the amount of times a student comes to class. So, and let's make m a constant and c also a constant, but we can just make c 0 for now, so for the sake of simplicity. So usually in machine learning, what we're trying to do is basically learn what m is, so that we can just run this equation and then get our value of y. So yeah, so coming back to the explanation about linear regression. So now I will try and show us what it looks like. Let me just get these guys off. Yep. So now, yeah, let's say we have a graph here, and we have the x and y axis. So let's say we have these guys. So here we have x and here we have y. So what else? So now the number of times, okay, so let's say here we have 0. Let's say we have basically let's just have values here. Let's have values here. So x, like I've said, is number of times a student comes to class. So let's make this 10, just for the sake of simplicity. So let's say this student came to class 9 times, and that student, let's have 0 here, and let's have 1 here. So 0 will be nope, the student is going to the student is going to fail, and 1 will be the student is going to pass. So I'm just trying to make a visual here so you can understand what I'm trying to represent. So yeah, this student comes to class 10 times, so there's a high probability of the student passing. This student came to class 10 times too. This guy also came to class, these are 9 times. This guy came to class 10 times. This guy came to class 10 times. This guy came to class 0 times. So you can see what we're trying to do here. We're basically modeling an idea. So most times when you have a data set, like you don't really know if this is true, like if the relationship is actually true, if the fact that a student comes to class more times, the student has a higher probability of passing exams, and if the student comes to class less times, he has a higher probability of failing exams. So, but we are just basically assuming here for the sake of learning. So this guy comes to class 0 times, is going to fail. This guy comes to class 0 times, is going to fail. This guy is going to fail. This guy is going to fail too. This one too is going to fail. This guy too is going to fail a little less than other guys who fail. This guy is going to fail. This guy is going to kind of pass, but he's not going to pass so well. This guy, we're just basically creating data points here, data points here, and then let's also have some outliers. Let's have some outliers. Yeah. Cool. So now, this is our data. This is all our data. Let's say we're visualizing all this data on our screen. Let's say with Python code, and we just got data from like a CSV file, and we're just throwing it all on the screen. So, what linear regression is basically is modeling this relationship. You can see that there's a relationship between X and Y. Like, it's obvious that the more this student attends class, the higher the probability of the student passing. Like we can see that here. So we want to model that relationship, and not just for visualizing, understanding past data. We also want to be able to predict a new variable, a new student attendance. Let's say a new student scores 8, came to class 8 times. We want to be able to predict how well that student would do in his exams. So now we're just using one variable. So to be realistic, a student passing an exam is not just dependent on the student coming to class. No matter if the student came to class, the student could come to class a lot. It could be about how much time the student spends reading. It could be a lot. So basically, if you're having a multivariate regression, a multivariate linear regression, what will happen is that you will have each of these variables relating to Y like this. You have an down here, you have an down here, you have an down here. So like that. And then the combination of everything gives you a model. So you can make predictions independently on all the variables and take everything together and have one final output, whether the student will fail a lot or the student will pass very well. So now so all we're seeing here is just data, and it will not always look so obvious like this. So what we're doing with a linear regression is we're coming with a line to highlight the relationship. So let's highlight the relationship. So let's say this. Now, doesn't mean these guys are wrong. They are just far away from our line, which is basically our prediction. And these guys, the distance between these guys, these variable points, and this blue line, our regression line, is the error. So this was a perfect prediction, a perfect prediction, a perfect prediction, a perfect prediction, a perfect prediction here, a perfect prediction here with little error. So a process of drawing this line basically is linear regression, which is basically the process of representing or modeling a relationship, a linear relationship between two variables. So so now that I've done that on the data we have, let's say we have new data that, oh, this new student, he came to class 7 times. Let's say 7 is here. So we're asking the AI or the model or the program, if we coded it, what's the probability that this guy is going to come to class, that this guy is going to pass his exams. So here, look at here, we just draw that based on our model says so there's huge probability. Let's say this is 0.7. There's a 70% probability that he is going to pass the exam, which is a good probability. So basically all I've explained right now is just linear regression. And so in machine learning, you can build a linear regression model that makes predictions based on certain inputs. If it's a simple linear regression, it's going to be one input, and then you're going to have constants. Basically. So now, this is x, this is y, but in this equation, y equals to mx plus b. I'm using b now. So we have our x and we have our y, and let's say b equals to 0. The value of y greatly depends on what m is. So what we'll be doing is basically using different algorithms, maybe gradient descent, to figure out what's the best m based on maybe our 1,000 or 100,000 data sets or examples that we have, so that when we have a new number of attendants, x, we can predict what the probability y will be. So so that's basically it on linear regression. So if you have questions, you can always hit me up and talk about it and stuff like that. So all right, bye.